Moving on to Chapter 4, Section 4, Grandmaster. We have some critical thinking problems. Number 1, express x to the power of 1 over 12 as a radical. Well, that's pretty easy. Okay, well, we know that the denominator here, that has to be the index. All right? And the fact that this numerator is a 1, well, that's nice. We can effectively ignore it. So this becomes a little 12. This. Okay. And we call this the 12th root of x, meaning that there's some number that if you multiply it by itself 12 times, you get x. Okay, so power, radical. Number 2, express x to the 1/12 again, but as a double radical, and are there other possibilities? What is a double radical? Well, I'll show you. Remember that 12, well, that's not prime. So let's see here. I'll do it this way. So x to the 1/12, okay, I can think of 1/12 as a product of two fractions. How about 1/3, okay, times 1/4? Okay, I just broke it down into two pieces. And, well, I can group the 1/3 with the x in brackets and then raise that to the 1/4. Okay, well, this I can write as a radical. Okay, x to the 1/3, that's just the cube root of x. But again, this is still being raised to the 1/4. Okay, well, something to the power of 1 over 4, I can write that as a radical. That's just the 4th root. So it's the 4th root of the cube root of x. So this is what a double radical is. It's when you have a radical that's inside a radical. Okay. Now, all these steps, well, normally you don't have to show this many, but look at the end result. Okay. We know that x to the 1/12 can be written as the 12th root of x. Well, if I want it as a double radical, I can just break it down into any factors or any combination that multiply to 12. So here are some other possibilities. So x to the 1/12, okay, again, that's just the 12th root of x, okay, but I wrote that as, well, this way. Why can't I reverse them? So I could write this as the cube root of the 4th root of x, okay, but 3 and 4, those aren't the only numbers that work. What about 2 times 6? Okay, so I could do the 6th root of the square root of x. Now normally I don't have to write this 2, so I actually won't. So whenever you're doing square root, by convention we don't write the 2. It's not wrong if you put it in, but on an exam or in a textbook it will not be written. And I can also change the order, so that's the same as saying the square root of the 6th root of x. So all of these are double radicals. Number 3, compare each pair of numbers using the appropriate inequality symbol. So less than, greater than. You may use a calculator just for these ones. So we want to compare the square root of 35 to 6. Okay? I would expect you to be able to do this one in your head actually, okay? Because we know that 6 is the square root of 36. But this is a bit smaller. Okay, so 6 is definitely larger, and remember, the mouth always eats what's bigger. Okay, but if you just want to check to see what is the square root of 35, or at least what is it close to, I'll just write it above. It's close to 5.916. ... Okay, which obviously is smaller than 6. Okay, let's work down. The cube root of 65, how does that compare with the number 4? Well, I know the cube root of 64 is 4. Well, my radicand is 65. That's slightly bigger. So I think it should be this. Okay. But let's use our calculator to compare. So if you don't have a cube root button, you can raise 65 to the power of 1/3, or you can use the X root button. Okay. Depending on your model, you might have to press numbers in different order. But you'll know you've done it right if you can get this. This is right above 4.0207 ... Okay, and that is obviously bigger than 4. All right, now we're comparing mixed radicals. We have 2 root 3 compared to 3 root 2. And no, they are not the same. Okay, we are allowed to use our calculator this time. So 2 times the square root of 3, okay, that's approximately 3.464 ... And I'm going to work out 3 times the square root of 2. That is approximately 4.242 ... So I think it's obvious now in decimal form which one's bigger. Okay, and there we go. Let's compare these guys here. 4 times the cube root of 3 with 5 times the cube root of 2. So let's see, the cube root of 3 times 4, you get about 5.768. I'm not rounding, I'm just chopping it off. And let's see, the cube root of 2 times 5, I get 6.299. Well, I think it's obvious that this one's bigger. Okay, so if you want to know if you're using your calculator correctly, just make sure that you can get these decimal approximations. Okay? All of these decimal approximations indicate that these radicals are irrational. Number 4, express each number as an entire radical and then compare using the appropriate inequality symbol. Do not use a calculator. Right? Well, all I'm doing is just comparing the exact same set of numbers as before. So we already know what the answer should be. We're going to try and do it without a calculator. Okay? Well, to do it without a calculator, one technique is to get the numbers looking the same. Okay? It's just like when you have two fractions and you want to see which one's bigger. It's a lot easier if you can find a common denominator. So, well, we're not doing that here, but it's sort of similar in that we want them to look the same. This is an entire radical. I'm going to write 6 as an entire radical. So remember, that is the same as the square root of 6 times 6. Okay, which is the square root of 36. Okay, so it's a lot easier now to compare root 36 with root 35. Okay, this 36 is obviously bigger, so we get the same answer as before. Okay, right. Cube root of 65 versus 4. Let's write this as an entire radical. So that just becomes the cube root of 4 times 4 times 4. So I need 3 factors, which is just the cube root of 64. So now they're similar in format, so it's easy to see that 65 is bigger than 64. Perfect. Next, okay, so we have mixed radicals here, so this 3 is trapped. So we're going to take this 2 and we're going to stuff it back inside. So this becomes the square root of 2 times 2 times 3. Okay, well, that's easy to do. That's just root 12. And then this one, this 3, it's going to get stuffed back in. So I'm going to get 3 times 3 times 2. And that's just root 18. Okay, so we can obviously compare 18 with 12. It's bigger. Okay, so we're getting the same answers. These ones here, and stuff this 4 back in. So this is going to be I won't actually show the work this time. Okay, 4 times 4 times 4. I can do that in my head. It's 64. Times 3, you get 192. Okay, so this is now an entire radical. And let's do the same thing here. So 3 factors of 5 inside. That's going to be 125 times the 2, 250. So I think we can safely say that. Oops. Here, I'll put it. That's originally what I'm comparing. And there we are. Number 5. Convert each expression to a mixed radical. Assume all variables represent unknown positive numbers. The reason why I have to say that is because things get a little tricky when numbers underneath are negative, particularly with square roots. So I'm just going to cover myself and just assume that all of these variables represent positive numbers. Okay? You'll deal with negative numbers in the future, so we won't worry about that now. Okay? So we're just going to break everything down. So the square root of 25x squared. Well, I know that that is 5 times 5 times x times x. Okay, that's just breaking everything down. And this is a square root, so we're just looking for groups of 2. Well, I have 2 groups of 5 and 2 groups of x. Okay, which is nice. That actually takes care of everything. So there's actually going to be no radical left over. So I'm going to have 1 factor of 5 here and 1 factor of x. Okay, so the square root of 25x squared is 5x. So there's no radical left over. Next, the square root of 12y cubed. All right. So just breaking everything down. So 12 is 2 times 2 times 3. And y cubed is just y times y times y. Okay, so square root, I want groups of 2. So there's a group of 2. Happens to be 2. And I have y times y. Okay. So this becomes 2 y, and then I have root of whatever's left, 3 times y, which is just 3y. Right? Not too difficult. Next one, however, is a cube root. So I just want groups of 3 instead of groups of 2. Okay, so how do I break down 80? It's not too difficult. All right, so 80 is 2 times 2 times 2 times 2 times 5, and then I have x to the 4th. Well, that's just x times x times x times x. Okay, so I'm going to extend this to make sure it includes everything. Okay. So cube root, I want groups of 3. So there's 1, and there's 1. Okay. And I have a 2, a 5, and an x, for which there's nothing I can do. So this becomes 2x times the cube root of whatever's left. 2 times 5 is 10, times x is just 10x. There we go. All right, next. Looks like we already have a mixed radical, and well, technically that's true. But by convention, when we create mixed radicals, we want to make sure that everything that was on the inside, when we're done, is as small as possible. So I'm actually going to start over here. Okay, I'll remove that. It's just so that I have more room, because this is going to expand quite a bit. So the 2x outside, that's fine. I'm just going to break down what's inside. So 125, That's just 5 times 5 times 5. Okay, no problem. X to the 8, well, that just means x times 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 x. Make sure everything is underneath. There we go. Okay, this is a square root, so I want groups of 2. Do that. It's actually not bad at all. In fact, the only thing that remains is 1 factor of 5. So this reduces quite nicely. Okay. So this is 2x. Okay. And what comes out? Well, this becomes 5. Okay. And this pair of x's, well, that becomes x. And then I've got 4 of them. Then, of course, I still have the root 5 still trapped. All right? So I'm just going to tidy up this mess as best I can. So 2 times 5 is 10. All right? And how many factors of x? Well, there was 1 to begin with, and I've added another 4. So this is just x to the 5th root 5. Okay, so the next one, again, just going to cross that out. I'm going to start a little bit further to the left so I have a little bit more room. This is 3 times the square root of, and 24 is 2 times 2 times 2 times 3. Okay, x squared is just x times x. Now, y to the 7. To be honest, I really don't want to write out y times itself and write out 7 of them. Okay. After all, with a square root, we're looking for groups of 2, groupings of 2. Well, if you look at the number 7, I can make 3 groups of 2, because 3 groups of 2 is 6, and there would just be 1 left over. So that's actually y squared times y squared times y squared times y. Because remember, if you multiply and you add up all these exponents, you're still going to get 7. All right. So I want groupings of 2. Do that. Do that. Now remember, y squared, that is y times y. So that in itself is a grouping of 2. Okay. Just to save space, I didn't write out y times y. Okay. So we pull out everything we can. So we have 3 times. So I can pull out the 2. Okay. I can pull out an x. Okay. So remember, this again is y times y. So outside it becomes y. And this becomes y. And so does this. And then I just have whatever's still left over. So I had a 2 times 3 times y, that's 6y. All right? So the best we can do is 3 times 2, that's 6. X, this can be written as y cubed times the square root of 6y. Okay, 2y times the cube root of 50x to the power of 7. Okay, so that's 2y times the cube root. Oop, that's a 3. Okay, so 50, how do we break that down? Oops. Well, that is 2 times 5 times 5. Okay. 2 times 5 is 10, times 5 is 50, and x to the 7. I really don't want to write out x 7 times here. Remember, we're looking for groupings of 3. So when it comes to 7 of them, I can make 2 groups of 3 with 1 left over. So this is going to be, do that. This is x cubed times x cubed times x. Again, just check. Do all your exponents add up to 7? Remember there's an invisible 1 here. Yes, they do. Okay. So groupings of 3, well, this is a group of 3. X times x times x. There's another one. But look at my numbers here. Okay, I broke down 50 as best I could, but I still do not have 3 prime factors that are the same. So there's actually nothing I can do. That 50 in its entirety stays. And the only thing I can pull out is these factors of x. So this becomes 2y. So this becomes an x, and that becomes an x, times the cube root of, I just have to put these back together. That's 50, and then I still have that x left over. All right. So tidy it up. By convention, well, usually we write them in alphabetical order. So this is 2x squared y times the cube root of 50x.